today because we will try to do one problem. We'll try to do the problem based upon the pre-stressed concrete, which we have discussed last two, 3 classes. Uh, I'll just read out the problem. A pre-stressed concrete beam of cross-section 300 by 400 mm is pre-stressed using a pre-compressive force of 500 kilonewton. The span of the beam is 10 meter. Find out the stresses in the upper and lower fibers of the beam at transfer. The tendons are placed exactly along the neutral axis. I read the question once again. I repeat. A pre-stressed concrete beam of cross section 300 mm by 400 mm is pre-stressed using a pre-compressive force of 500 kilonewton. So the width of the beam is given, which is 300, depth of the beam is given, which is 400, and it is pre-stressed using a pre-compressive force of 500 kilonewton, meaning initial pre-stressing force is given, which is 500 kilonewton. The span of the beam is 10 meter, so L is 10 meter. Find out the stresses in the upper and lower fibers of the beam. So sigma u is equal, we need to find out upper stress, this one, because previous classes you would have seen this sigma u and sigma L, the stress at top and stress at bottom. Okay, and another thing is the upper and lower fibers of the beam at a transfer. Okay, right. Then another thing is the tendons are placed exactly along the neutral axis. So the previous problems, if you see, this is the tendons and which is placed at a distance from the neutral axis. So it is called eccentricity. Here the tendons are placed exactly on the neutral axis. So meaning is that your eccentricity is 0. Okay, so it is placed like this. So eccentricity is 0. So let us see. Because as discussed before, because of the pre-stressing force, it will try to, the steel will try to shorten, so it will be a compression in nature. So it will be, first one will be P0 by A, first one. Second one, this P0E by Z will not come in picture. This will be 0 because the tendons are exactly on the neutral axis. It will not create any bending moment. P into E will not come because E is 0. So this second time will be 0. The third one is, it is question is fibers of the beam at transfer. At transfer, what are the loads will come? P0 and dead load. Right. Okay. So the dead load, what will happen when the load applied? Dead load, it will bend like this. So, okay. Top compression, bottom tension. Right. So it will come like this: top compression, bottom compression is positive, tension is negative. We need to find out the stress. Stress is moment by modulus of section, M by Z, MD by Z. D is because of dead load, MD by Z. So this is our formula: sigma u is equal to P0 by A, positive compression, minus P0. This time is not there, so we no need to show it, this one. Okay, plus MD by Z. And that is the upper fiber stress, and lower fiber is P0 by A minus MD by Z. Okay, so we need to find out P0 is given to you. P0 by A we need to find out. P0 is 500 into 1000, converting into Newton, divided by area 300 into 400. So 4.16 Newton per millimeter square will come. MD is moment due to dead load. That is nothing but the load into L square by 8. Consider it as a simply supported beam. So WD into L square by 8. So WD is equal to 0.3. How to find out the self weight? Area of the cross section into thickness, into unit weight of concrete. Okay, I am taking 1 meter length. So 0.3. B is 0.3. D is 4. So 0.3 into 0.4 into 25. So this is equal to 3 kN per meter. That is the dead load. Therefore, moment is WD into L square by 8. So 3 into 10 square. Span is 10 meter. W into L square by 8. So you will get 37.5 kilonewton meter. Okay. So you got P0, you got A, you got MD. So next remaining is Z. Z is nothing but cross section, section modulus, which is for a rectangular section. Ours is rectangular section. It is BD square by 6. So B into D square by 6, you will get 80 into 10 to the power 5 millimeter cube. Therefore, MD by Z is, substituting MD by Z, you will get 4.68 Newton per millimeter square. So your upper fiber stress will be P0 by A plus MD by Z. Plus is, I told you why, because it will bend down only. So top compression, bottom tension. So substituting the values, you will get upper fiber stress is 8.84 Newton per millimeter square. Similarly, lower fiber stress is P0 by A minus MD by Z. Minus because this reason. Dead load, no? Bottom it is tension. So it is minus. Is equal to 0.52 Newton per millimeter square. That is the end, and we need to draw the stress diagram. Top it is 8.84, bottom it is negative 0.52. So our stress diagram will be like this. Okay, that's all. Thank you very much.